Student, next one, method of removing permanent hardness of water. Okay, student, this can be removed by the method named as permutate, which is called actually zeolite. Zeolite is an inorganic resin. Therefore, this method is again and also known as inorganic resin method. That is, here we are using some inorganic resin which are called zeolite to remove the permanent hardness of water. Student, what is the reason of permanent hardness of water? So we have discussed earlier that the presence of soluble chlorides and sulfates of calcium and magnesium. That means what? Calcium and the magnesium inorganic salt, these are responsible for the permanent hardness of water, because these ions exchange the sodium present in the soap and therefore they degraded the soap. When they degraded the soap, now the soap is not able or say unable to give the foam or lather with the soap solution. Besides of it forms precipitate called scum. So if we remove these ions from the hard water, then the water will become soft. Thus, to exchange these ions, we are using an inorganic resin which is called zeolite. So, what are zeolite? Chemically, zeolite are sodium, aluminium, silicates. Student, there are a lot of silicates. Out of these, we are selecting one particular silicate. This is called Na2Al2SiO8. This is called a zeolite. Getting? Actually, in very short, we can denote it by Na2Z. Here Z stands for zeolite. That is, besides of writing a big formula, we can write a simple presentation Z, which is stand for Al2SiO8 and called zeolite. So, when this zeolite is introduced with the hard water, now what are the hard water? Hard water which consist Ca2 cation or which consist Mg2 cation. When we introduce with sodium zeolite, now the calcium salt will convert into calcium zeolite and the magnesium will convert into magnesium zeolite. Isn't it? And thus the sodium cation will what? Free. That means what? That means the responsible cations present in hard water is now exchanged with the zeolite. Thus now there will be only Na cation, and Na cation is not responsible for hardness of water. Thus the water will be free from all type of impurities, that is soluble impurities of calcium and magnesium ions. For this, what we are doing, we are using a big vessel. In this vessel, the first one, we are adding a white fine sand, okay, like that, white fine sand, and some small pieces of stones over it. That is a bed of stone, and a sand is prepared. They also absorb the impurities present in the water, that is in the dirty water. Then a big layer of zeolite is added there. It is a white solid, okay, spongy in nature. Spongy in nature. Its formula is Na2Al2SiO8, sodium silicate. Now from the top, that is from this point, The impure water, that is, you can say simply what? Hard water. Hard water is poured. Okay. When this hard water runs through it, first it filters with the sand and the stone bed, and then it filters with the sodium silicate. Here the ion exchange takes place. Ion exchange means what? The zeolite exchange calcium or magnesium present in the hard water. So this is called ion exchange. And thus in this part a pure water gets obtained. This pure water is now take off. That is what? Pure, or you can say what? Soft water. Pure or soft water. So student, this is very important and very easy process. In earlier water filter, which consists the two vessel, if you try to remind, the first vessel consists a candle, white color cylindrical candle, through which the water gets filtered. This candle is actually what? The sodium zeolite. Okay, you can check in your water filter. Even in the big water, that is the modern water filter, you will find the two rods are there. This is the white color rods. Actually, this white color rod consists what? Sodium silicate, which exchanges the cation present in the hard water.